Okay, so let's say that we want to find all of the roots of that given polynomial function, and that they want us to find these roots by using synthetic division. And we know that there are going to be 4 roots because this polynomial is of degree 4. They've given us one of the roots, and they've given us this root here. So let's go through synthetic division, and the anticipation is that because this is the root of this polynomial, we expect that this synthetic division algorithm will give us a remainder of 0. Let us confirm that. So recall how this works. You drop the 1 here, and then you go 1 times that, and then you add these numbers. You add this complex number with this real number, and that gives you back this here. And so now we have to go this times this. Maybe what I can do is I can have a second piece of paper where I do my scratch work. Let me go 1 plus I times negative 1 plus I, and let's expand. So that'll be negative 1 plus I minus I plus I squared. And these eliminate. And this is negative 1. I squared is negative 1, so that's negative 2. So I multiplied these guys here on this paper, and I got negative 2. Add these, that's negative 3. And now multiply this with that. I can distribute that in my head. That'll be negative 3 minus 3i. Add these. That'll be positive 3 minus 3i. And then back to my scratch paper. This time I'm going to go 1 plus I times 3 minus 3i. Let us expand this product. That'll be 3 minus 3i plus 3i minus 3i squared. These eliminate. This will be 3 minus 3 times negative 1 because I squared is negative 1. And this gives us back 6. And we knew that because the remainder was supposed to be 0, which means that these should eliminate. Now, we continue with synthetic division. You might wonder that this is not possible because they only gave us 1 root, but in reality, they give us 2. Because one of the roots was complex, that means that its conjugate will also be a root. And if you have a polynomial, if one of the roots is complex or imaginary, then its conjugate will also be part of the set of zeros, right? The collection of zeros. You have 2 answers. I need 4 of them. We have 2 of them so far. So let me continue with my coefficients here with this number. Okay, so let's drop this guy here. And then we have 1 times that is 1 minus I. And if you add these, you get 0. And if you go that times that, it's 0. You add those, that's negative 3. You distribute, that's going to be negative 3 plus 3i. And the remainder is 0. This always happens, where when you plug in a complex number, and the first time it's kind of weird and you need scratch paper. But then when you go through and you throw in the conjugate, it works out nicely with a bunch of zeros and stuff, with a lot of elimination. So now here's what you want to do. I have 2 answers, but I need 2 more because the degree was 4. I need 4 answers. I have 2 of them. I need 2 more. And those 2 answers are hiding right here. Build an equation from this. This is going to give us an equation. You see, this is the remainder. This is a constant. This is x, and this is x squared. So the equation that comes to life from these coefficients would be x squared minus 3 equals 0. 0x disappears because it's 0. And the x squared minus 3 is there. Let's solve this equation. Why don't you add a 3 to this side? You can square root both sides. And we have plus or minus the square root of 3. So if they wanted your roots or your zeros, whatever you want to call them, they would be 1 plus I, 1 minus I, square root 3, negative square root 3. If they wanted sort of the linear factorization, then it would be x minus 1 plus I, x minus 1 minus I, times, ran out of space, I'll continue here, x minus square root 3 times x plus square root 3. In any order, the order doesn't matter. The point is that f of x as a linear factorization would be these 4 here. If you take these 4 parentheses and if you multiply them, you're going to get back the original polynomial, which was in standard form. But this is the linear factorization. It's x minus, x minus, x minus, x minus, all of these guys here. And just in case you're wondering why this one was plus, is because when you go x minus the negative square root 3, the double negative turns it into a positive, right? So anyways, this is the linear factorization, and this is your list of roots.